Hello, my name is David McMullan, and I teach the first year module that's called Mathematical Reasoning. Now, what this module is really about are numbers. Not a surprise in a mathematics degree, but these are actually the counting numbers. And it's not really just the counting numbers we're interested in, but what we really want to try to understand are these prime numbers. So we see we have 2, it's the only even prime number, the rest of them are all odd. And then we see numbers that are kind of close together or further apart as we go along this list. So here we see all the numbers that we're listing that are prime all the way up to 100. So the thing that's kind of interesting for us is to know, how do we describe these numbers? How do we find these numbers? And how do we use these numbers? And the surprising thing at the end of the course is that there's an awful lot of very important uses of these numbers. Now, to describe these numbers is really quite fundamental in mathematics. And one of the things that's kind of really interesting is here we have the thing called a prime number theorem. And it says that we have a function, pi, that counts the number of prime numbers up to the value x. And the surprising thing here is we see it's actually given in terms of a nice integral. So this tells us that we actually understand quite a lot about these numbers. But the real challenge is, how do we find them? Now, finding the numbers up to 100 was quite simple. There's a nice little algorithm called a sieve of Aristophanes that we'll discuss. But how do you find big prime numbers? And when I mean big, I mean really big. So for example, here we have a 100-digit prime number. Now, this is not even big enough for us. So in this module, we will want to understand how to find 300-digit prime numbers. Now, these numbers are huge. You cannot just check if they're prime by looking for all their factors. So we need a much more sophisticated approach. We need to understand deeper results about prime numbers, but we also need to understand how to translate what we've understood into computing programs that will allow us to calculate these numbers. So this module is going to be a lovely mixture of fundamental mathematical theorems that we then implement using modern computer languages. And the language we use in this module is Python. So using Python, we will actually generate algorithms, all to do with this RSA system. And we will be generating, for example, here, 300-digit prime numbers and using them to encrypt systems and make secure messages. This is something that is very important in modern society. There's an awful lot of very significant jobs related to this type of security. And what it is all about, fundamentally, are prime number theorems. So within this module, we will equip you with these kind of very, very interesting bits of mathematics that will then allow you to use them in other modules, but also in ways of getting better jobs. So I hope you'll enjoy the module when you come here. Goodbye.